find the area between two curves. And our first step is to sketch the graph of the curves. So let's start up. We'll have a little bit of review of sketching the cosine graph. So we start with y equals cosine pi x. And in order to sketch the graph well, which we need to do, I'm going to find the period. And to find the period, I take 2 pi and divide by the coefficient of x, which is pi. So I put that over there, and I get the period is 2. So we don't usually see that in our calculus books that much, where you have the period a whole number. But why not? Okay. So let's then pull out a good color for this graph. Okay, the amplitude is 1. It's just that the period has changed to 2. Now, in order for me to do this, I need to assign what I mean to, okay. I need to assign a unit value here just to draw this well. It's at this time that I think it wouldn't just be sort of easier if I were not using graph paper, if I didn't have this idea that I had to draw this so well. But anyway, okay, let me just draw this guy here. But this is 2. But if I do that, now the x and y aren't to scale. So what I did is I just drew the cosine graph, and I just said, okay, that period is 2. But if I do it but I didn't change the amplitude, I could just say, well, that's 2 over here. But why don't I try a little harder to make x and y to scale? Let me just do the correct graph like this, so I can get x and y to scale. Okay. So there's the cosine graph, and the amplitude is, all right, so now I'm, okay. The amplitude is 1. So, all right. So in this picture here, 2 squares make 1. The thing is, if I didn't have graph paper, I wouldn't have to start dilly-dallying with all this. Okay. So, but I do have graph paper, and I got too into it, too excited about graph paper. All right. So this is going to be -1 over here. But now, all right, so this is my cosine graph. But let me now play around with this other graph and see how smoothly that goes. So if I have y equals 4x squared minus 1, this is a parabola that faces up, right? This is a parabola. Faces up. I'm going to find the x-intercepts because I think that's sort of like easy stuff. And if I do 4x squared minus 1 equals 0, I'll get 4x squared equals 1, x squared equals 1/4. So x will equal plus or minus 1/2. And then also, this is in a standard form for a parabola. So we should see what the vertex is. The vertex is going to be 0, -1, because the standard form is y equals ax minus h squared plus k, and the vertex is hk. So I can just compare. I have x minus 0 squared, so the h is 0, and then k is -1. So, but it's important this, now to go back to my nice little graph over here, that I see where -1/2 is. Those are the x-intercepts, and actually, without doing any more here, I can find the where these two graphs intersect. So it looks sort of like this. Let me do one of these and use the graphing program that, oh, maybe that was a mistake, to try to fiddle around with this. Gosh. It's like I'm playing around with a, I don't know, like a grease pig or something. Okay, let's see. If I put in 1, I get 4 times 1 squared. Okay, it's gonna be 1/3. Oh, it's coming together. Is it? 4 times 1. Oh no, 3 is way off, way above. Okay, that's again, like, am I really going to try to, all right, let me just do my graph like this. Just do that part of the problem. Okay, I was using the program where they, okay, anyway, but this is our bottom function. And okay, so I have y equals, on the bottom, 4x squared minus 1. And the top, I have y equals cosine pi x. And then, I mean, I overdid it on the cosine graph. I didn't have to do so much, but it's okay. I'll just color in the part that I want. Hey, do you guys see any symmetry here? The answer is yeah. See symmetry? Like, would it help or make this easier if I only integrated from 0 to 1/2 and double the answer? Maybe that would make it easier. I don't think there's symmetry around the x-axis at all. It sort of looks like it, but I don't think there is. So the symmetry that I'm talking about is that I think there's symmetry around the y-axis. And so what I could do, but it maybe won't make anything easier, but I think it might, is that if I just integrate from 0 to 1/2 and double the answer. So area is going to be the integral from a to b f of x minus g of x dx, where I have the top minus the bottom. So in this situation, that is going to be from negative 1/2 to 1/2, and I have the top being cosine pi x, and the bottom being 4x squared minus 1. And by the way, I don't see that I could, the way you algebraically find points of intersection is you set the two functions equal to each other and solve. You can't do that with this problem. It's actually, you can't solve functions, equations that have cosine x and a polynomial. So it just was cleverly thought out by the author to make it so that we could find the points of intersection simply by carefully sketching the graph. But you wouldn't be able to do it by an algebraic method. All right, so again, I'm going to take this and double it and just go from 0 to 1/2. And then I'll integrate. Distribute that negative properly. Okay, so this is going to give 2. The antiderivative of cosine x is just plain old sine x. All right, the problem with this is it's not a big problem, but we have to use substitution for the integral of cosine pi x. However, you can sort of just think about it. Just think about what's going on here and just take a guess. Okay, let's just without using use substitution here, maybe I should do the use substitution, but oh gosh, it's going to make it take longer. But look, let me just without use substitution. The derivative of sine pi x is cosine pi x times the derivative of what's inside, which is pi. The derivative of pi x is pi. So I don't see a pi here. So what I have to do is I have to divide by pi. Okay, let me come back and do that on the side of the paper. For 4x squared, I get 4x cubed over 3. For 1, I get x. And we're going from 0 to 1/2. All right, let's do an aside. The integral of because I want you to show all your work on your test. So, okay, cosine pi x dx. With that u equal pi x, du is pi dx. So 1 over pi du is dx. So we have the integral of cosine pi x, so it's going to be cosine u, and then dx is 1 over pi du. And then the antiderivative of cosine is sine. Then we have plus c, and we have that 1 over pi. So that makes 1 over pi sine pi x. So that's the substitution method. Okay, now let's see if I can plug these numbers in and get this right. So I have 2 over pi sine pi x from 0 to 1/2 minus 8/3. Maybe I won't do all this. Okay. All right, I'm just going to do it this way. So 2 times 4 is 8. So minus 8/3 x cubed from 0 to 1/2 plus 2x from 0 to 1/2. All right, so this is going to be 2 over pi. Sine of pi x is going to make sine of pi times 1/2, so it's sine of pi over 2, minus sine of putting in 0 gives sine 0. Sine of pi is pi over 2 is 1, sine of 0 is 0. Minus 8/3, 1/2 cubed, minus 0 cubed, plus 2, 1/2 minus 0. My aside got in the way. The aside work is in the way. So this makes 2 over pi times 1 minus 8/3 times 1/8 plus 2 times 1/2 is 1. So this makes 2 over pi minus 1/3 plus 1. So this makes 2 over pi minus or plus 2/3. Stewart will get a common denominator. I don't think so. I think he'll leave it like that, or maybe he'll factor out the 2, or maybe I just got a plain wrong anyway. That answer is for number 19, 6.1, number 19, 2 over pi plus 2/3. Yes. Woo. Got it right. Nice. Does it again. Okay. I can still keep my job for maybe 1 or 2 more years before I lose my mind. Yes. Okay. Any questions before I move on to the next thing?
Will you just leave it for just a second?
I'm going to turn off the video first, though. Okay.
Oh.